Designing an engaging and effective mathematics curriculum for primary school students. Curriculum design for effective mathematics teaching at the primary school level involves careful planning and consideration of various elements. It requires a systematic approach to ensure that young students receive a comprehensive and enjoyable mathematical education, from establishing learning goals to incorporating hands-on activities and age-appropriate resources. Each step plays a crucial role in shaping the curriculum. Here are the steps and key elements involved in designing a mathematics curriculum for primary school. Identify age-appropriate learning objectives. Establish educational standards for the primary level. Organize content in a logical and sequential manner. Determine the scope and sequence of topics. Select engaging instructional materials suitable for young learners. Design assessments that align with the learning objectives. Incorporate differentiation strategies to cater to diverse student needs. Integrate real-world applications to make math relevant and meaningful. Utilize appropriate technology tools and resources. Continually review and improve the curriculum to enhance student learning. Establish educational standards for the primary level. Begin by understanding the educational standards set for primary school mathematics education. These standards serve as guidelines that define the expected learning outcomes and content for each grade level. For example, in some countries, the national or regional curriculum frameworks provide a comprehensive outline of what students should learn and understand in mathematics at each stage of primary education. These standards cover various domains of mathematics, such as number sense, operations, geometry, measurement, and data analysis. To exemplify this step further, let's consider the national curriculum standards for primary school mathematics. These standards outline specific expectations for each grade level and provide a clear progression of skills and concepts. For instance, in number sense, the standards might include topics such as counting, comparing quantities, understanding place value, and performing basic operations. By identifying and familiarizing yourself with these educational standards, you ensure that your mathematics curriculum aligns with the expectations set by the education system. This alignment helps establish consistency across classrooms and ensures that students are adequately prepared for subsequent grade levels. Additionally, being aware of the standards allows you to track student progress and identify areas that may require additional attention or intervention. Identify age-appropriate learning objectives. Based on the developmental stage of primary school students, establish clear and age-appropriate learning objectives that define what students should know and be able to do by the end of the year or unit. These objectives should be specific, attainable, relevant, and time-bound, SMART goals. For example, let's consider a unit on addition and subtraction for primary school mathematics. Based on the educational standards and the cognitive abilities of young learners, the learning objectives could be: objective, students will be able to add and subtract single-digit numbers. Specific, students will learn to add and subtract numbers from 0 to 9. Measurable, students will demonstrate their understanding by solving a variety of addition and subtraction problems correctly. Attainable, the objective is within the grasp of primary school students who are developing their basic arithmetic skills. Relevant, addition and subtraction are foundational skills in mathematics and essential for building number sense. Time-bound, students will achieve proficiency in adding and subtracting single-digit numbers within a specific time frame, such as 2 weeks. By establishing age-appropriate learning objectives, you provide a clear direction for both yourself and your students. These objectives help you focus your instruction, design suitable assessments, and effectively track student progress. Setting SMART goals ensures that the objectives are specific, achievable, and aligned with the developmental needs of primary school students, promoting successful mathematics teaching and learning. Organize content in a logical and sequential manner. Break down the mathematics curriculum for primary school into coherent units, modules, or chapters that align with the structure of your school's program. Group related topics together to create a logical progression of concepts, ensuring that prerequisite knowledge is addressed before introducing new material. To exemplify this step, let's consider an example of organizing content for a primary school number sense and operations unit. Here, we will outline the structure of units and their logical progression. By organizing the curriculum into units or modules, you provide a structured framework that allows for a logical progression of concepts suitable for primary school students. Each unit builds upon the foundational knowledge and skills developed in the previous one, ensuring a solid understanding of mathematics. This sequential approach promotes a gradual increase in complexity, helping students develop strong number sense and operational skills. Within each unit, you can further organize the content into lessons, activities, and hands-on experiences. This division allows for focused instruction and meaningful practice, ensuring that students grasp each concept before moving on. Furthermore, organizing the content in this manner facilitates effective planning and instructional delivery, allowing you to allocate appropriate time for each unit and ensure comprehensive coverage of the curriculum. Determine the scope and sequence of topics. Establish a logical and developmentally appropriate sequence in which topics will be taught in the primary school mathematics curriculum. Consider how concepts build upon one another and ensure that the curriculum covers the necessary content while allowing sufficient time for students to develop a deep understanding. To further illustrate this step, let's focus on sequencing and scoping topics for a primary school geometry curriculum. By carefully sequencing the topics, you ensure that students progress through the curriculum in a logical and developmentally appropriate manner. Each unit builds upon previously learned concepts, allowing students to develop a deep understanding of geometric principles. For example, before exploring measurement concepts, students first learn to recognize and describe shapes, laying the foundation for understanding attributes such as length and area. Additionally, scoping the curriculum involves ensuring that the necessary content is covered while providing sufficient time for students to explore and grasp the material. Geometry introduces students to fundamental spatial and visual reasoning skills. Allowing ample time for hands-on exploration, problem-solving activities, and reflection enables students to develop a solid foundation in geometry. Regular formative assessments, feedback, and student engagement are crucial to monitor progress and make adjustments as needed. This approach ensures that students have the opportunity to build a strong understanding of geometry and are well prepared for future mathematical studies. Select engaging instructional materials suitable for young learners. Choose appropriate textbooks, workbooks, online resources, and supplementary materials that align with the primary school math curriculum and support the learning objectives. Consider materials that are visually appealing, interactive, and age-appropriate to engage young learners and promote their mathematical development. To exemplify this step, let's consider instructional materials for a primary school math curriculum. Textbooks. Select textbooks that present math concepts in a clear and accessible manner for young learners. Look for textbooks that include colorful illustrations, simple language, and age-appropriate examples. Consider textbooks that provide a variety of hands-on activities, games, and real-life connections to make math more engaging for primary school students. Workbooks and practice resources. Choose workbooks or practice resources that offer a range of activities and exercises that align with the curriculum. Online resources. Explore online platforms or websites that offer interactive math games, educational videos, and virtual manipulatives. Supplementary materials. Incorporate supplementary materials that provide additional practice, enrichment, and real-life applications of math concepts. Multimodal resources. Choose materials that cater to different learning styles and provide multiple representations of math concepts. By carefully selecting engaging instructional materials, you create a stimulating learning environment for young learners. These materials should not only align with the curriculum but also promote active participation, critical thinking, and problem-solving skills. Regularly review and update the instructional materials to ensure they remain relevant, age-appropriate, and aligned with best practices in primary school math education. Design assessments that align with the learning objectives. Develop a range of formative and summative assessments to measure student progress and achievement of learning objectives in primary school math. Assessments can include quizzes, tests, projects, observations, and hands-on activities. Ensure that the assessments align with the math curriculum and provide meaningful feedback to guide instruction and support student learning. To exemplify this step, let's consider assessment design for a primary school math curriculum. Quizzes. Design short quizzes to assess understanding of specific math concepts or skills. Tests. Develop comprehensive tests that cover various math topics taught throughout the year. Projects. Assign hands-on projects that allow students to apply their math knowledge in real-world contexts. Portfolios. Implement portfolio assessments to track student progress over time. Performance tasks. Incorporate performance-based assessments that require students to demonstrate their math skills in authentic tasks. Observations. Use ongoing observations and anecdotal records to assess student understanding during math lessons and activities. When designing assessments, ensure that they align with the curriculum and learning objectives. Clearly communicate the expectations and criteria for each assessment to provide students with clear guidelines and transparency. Additionally, provide timely and constructive feedback to students to guide their learning and improvement. Assessment results should inform instructional decisions, such as adjusting teaching strategies, providing targeted interventions, or offering additional support where needed. Remember to use a mix of formative and summative assessments to assess student progress throughout the year. Formative assessments provide ongoing feedback to inform instruction and allow students to monitor their learning, while summative assessments measure overall achievement and provide a comprehensive evaluation of student understanding. By incorporating various assessment methods, you can gather a holistic view of student learning, provide meaningful feedback, and support their growth in mathematics. Incorporate differentiation strategies to cater to diverse student needs. Consider the diverse needs of your primary school math students and plan for differentiation strategies to support learners with varying abilities and learning styles. Provide extension activities for advanced students and additional support for struggling students. To exemplify this step, let's explore differentiation strategies in a primary school math class. Flexible grouping. Utilize flexible grouping strategies to accommodate different learning needs. Group students based on their abilities, interests, or preferred learning styles. For example, you can create small groups for collaborative problem-solving tasks or assign individual activities tailored to specific skill levels. Tiered assignments. Design tiered assignments that provide different levels of complexity or depth. Provide advanced students with more challenging math problems that require critical thinking and problem-solving skills, while offering additional support and scaffolding for struggling students. For instance, in a unit on addition and subtraction, advanced students may be tasked with solving multi-step word problems, while struggling students focus on simple addition and subtraction exercises. Varied resources. Provide a variety of resources to cater to different learning styles and abilities. Offer manipulatives, visual aids, math games, or online interactive activities to enhance understanding. For example, when teaching fractions, you can provide fraction tiles or visual models for tactile learners, while incorporating visual representations and interactive games for visual learners. Scaffolded support. Break down complex math concepts into smaller, more manageable steps and provide scaffolding to support struggling students. Offer visual step-by-step guides, graphic organizers, or concrete examples to help them grasp the concepts. Gradually reduce the level of support as students gain confidence and proficiency. Enrichment activities. Offer extension activities or enrichment opportunities for advanced students to deepen their understanding of math. This can include challenging math puzzles, open-ended problem-solving tasks, or exploratory projects that encourage creativity and critical thinking. Individualized support. Provide individualized support and differentiated assignments based on student needs. Offer one-on-one or small group instruction for students who require extra assistance. Adjust assignments, assessments, or instructional materials to match their learning pace, language proficiency, or cognitive abilities. Regularly check in with these students to monitor progress, address challenges, and provide personalized feedback. Differentiation allows for a more inclusive and personalized learning environment that caters to the unique needs of each student. By incorporating differentiation strategies, you create opportunities for all students to succeed, challenge themselves, and reach their full potential in the math classroom. Regular assessment, observation, and collaboration with students and their support networks can help inform the differentiation strategies and ensure that each student's needs are effectively addressed. Integrate real-world applications to make math relevant and meaningful. Include opportunities for primary school math students to apply mathematics to real-world situations. Connect mathematical concepts to everyday life, practical situations, and other subjects to enhance student motivation and understanding. To exemplify this step, let's explore how real-world applications can be incorporated into a primary school math course. Everyday objects. Use everyday objects and scenarios to introduce mathematical concepts. Students can count and compare objects in their environment, measure ingredients while cooking or baking, or calculate the cost of items during a pretend store activity. This helps them understand the practical application of numbers and basic arithmetic operations. Measurement and time. Connect measurement and time concepts to daily activities. Students can measure objects using non-standard units like paper clips or blocks, compare lengths and weights of different objects, or read and interpret time using clocks and calendars. This allows them to understand the importance of measurement in their routines. Money and financial literacy. Teach students about money and financial literacy by incorporating real-life examples. They can practice counting and making change with play money, create budgets for classroom activities, or learn about saving and spending through role-playing exercises. This helps them develop practical skills for managing money. Data and graphs. Introduce data and graphing through real-world examples. Students can collect and organize data by conducting surveys or recording class preferences, then represent the data using simple graphs or charts. They can analyze the information to draw conclusions and make comparisons. This fosters their ability to interpret and communicate information visually. Shapes and patterns. Explore shapes and patterns in the world around us. Students can identify shapes in their environment, create patterns using objects or colors, or design their own symmetrical patterns. This helps them recognize geometric shapes and develop spatial awareness. Problem solving in context. Present math problems in real-life contexts. Students can solve word problems related to everyday situations, such as sharing objects among friends, measuring ingredients for a recipe, or planning a party. This encourages critical thinking and problem-solving skills while making math relevant to their lives. By incorporating real-world applications, primary school math students can see the practicality and relevance of mathematics in their everyday lives. It helps them understand that math is not just an abstract concept but a tool they can use to solve problems, make decisions, and navigate the world around them. Utilize appropriate technology tools and resources. Integrate technology tools suitable for primary school math education, such as educational apps, interactive websites, digital manipulatives, and online resources, to enhance student engagement and provide interactive learning experiences. To exemplify this step, let's explore how technology can be incorporated into a primary school math curriculum. Educational apps. Utilize educational apps designed for primary math education. These apps offer interactive activities, games, and exercises that engage students in practicing math skills and concepts. For example, students can use math apps to solve puzzles, practice counting and number recognition, or engage in virtual math challenges. Interactive websites. Utilize interactive websites that provide math games, simulations, and virtual manipulatives. These websites offer interactive tools that allow students to explore concepts like addition, subtraction, shapes, and patterns in a hands-on manner. Students can manipulate virtual objects and engage in interactive activities to deepen their understanding. Digital manipulatives. Utilize digital manipulatives on tablets or computers. These digital tools simulate physical manipulatives, such as base 10 blocks, fraction tiles, or pattern blocks, allowing students to visually and interactively explore math concepts. Students can use digital manipulatives to practice counting, sorting, comparing, and problem solving. Online resources. Utilize online resources, such as math tutorials, videos, and printable worksheets. Online resources provide additional explanations, demonstrations, and practice materials that can support classroom instruction. Students can access instructional videos to reinforce concepts, solve online math problems, or print worksheets for independent practice. Data collection and analysis. Introduce basic data collection and analysis using technology tools. Students can use digital tools, such as simple spreadsheets or online graphing tools, to organize and analyze data. They can collect and represent data from class surveys or conduct simple experiments to practice data analysis skills. Virtual math manipulatives. Utilize virtual math manipulatives that allow students to explore math concepts in a digital environment. Students can interact with virtual base 10 blocks, pattern blocks, or fraction bars to understand place value, geometry, and fractions. These virtual manipulatives provide a visual and interactive approach to learning math concepts. Online collaboration and communication. Promote online collaboration and communication platforms suitable for primary students. Students can engage in online discussions, share math-related ideas, or work collaboratively on math projects. This encourages teamwork, communication skills, and a sense of community among students. By incorporating technology into the primary school math curriculum, students can engage in interactive and dynamic learning experiences that enhance their understanding of math concepts. Technology tools provide opportunities for interactive practice, visualizations, virtual manipulations, and collaborative learning. It fosters student engagement, critical thinking, and problem-solving skills. Additionally, the use of technology prepares students for the digital age and equips them with essential skills for future educational and professional endeavors. Continually review and improve the curriculum to enhance student learning. Regularly review the primary school math curriculum and seek feedback from students, colleagues, and parents. Use data from assessments to identify areas for improvement and adjust the curriculum as needed to better meet the needs of students. To exemplify this step, let's explore how a primary school math curriculum can be continually reviewed and improved. Reflect on student feedback. Conduct a class discussion or use student surveys to gather feedback on the math curriculum. Ask students about their favorite math activities, concepts they find challenging, and ideas for making math more enjoyable and relatable. Consider their input when planning future lessons. Collaborate with colleagues. Schedule regular meetings with other math teachers in your school or district to discuss curriculum design and implementation. Share lesson plans, teaching strategies, and student work samples. Collaboratively address challenges and brainstorm ideas for enhancing the curriculum. Analyze assessment data. Review assessment results to identify specific math skills or concepts where students may need additional support. If a significant number of students struggle with fractions, for instance, consider dedicating more instructional time to reinforce and practice this concept in future units. Seek parent involvement. Conduct a parent-teacher meeting or send out a survey to gather parent perspectives on the math curriculum. Ask for their observations, concerns, and ideas for improving math instruction. Consider their feedback when revisiting and refining the curriculum. Stay updated with research and best practices. Stay connected with math education organizations, participate in online communities, and explore reputable resources that provide insights into effective math instruction. Incorporate research-based strategies, such as hands-on manipulatives or problem-solving tasks, into the curriculum design. Continual review and improvement of the primary school math curriculum ensure that it remains engaging, relevant, and aligned with students' needs. By actively seeking feedback, analyzing data, collaborating with colleagues, involving parents, and staying informed with current research, educators can make informed decisions to enhance the curriculum and provide a meaningful and effective learning experience for students. Remember that effective mathematics teaching goes beyond curriculum design. It also involves engaging instructional strategies, effective classroom management, ongoing professional development, and building a positive learning environment to foster student success. In conclusion, designing an effective mathematics curriculum at the primary school level is a multifaceted process that requires attention to various aspects of teaching and learning. By incorporating the key elements outlined in this discussion, educators can create a curriculum that promotes a strong foundation in math and engages young learners. From utilizing instructional strategies to managing the classroom effectively, each component contributes to a positive and meaningful mathematics education. Additionally, ongoing professional development and creating a supportive learning environment play a crucial role in fostering student success. By embracing these principles of curriculum design, educators can provide young students with the necessary skills, critical thinking abilities, and a lifelong love for math. As we conclude this presentation, I invite you to reflect on the importance of curriculum development in primary math education and the impact it has on shaping the minds of future scientists and innovators. Let us continue our shared commitment to providing quality math education, adapting to the ever-changing landscape, and inspiring the next generation of curious minds. Together, we can make a lasting difference in the scientific journey of our students. Thank you once again, and I wish you all continued success in your teaching. You can access the comprehensive PDF document associated with this presentation through the Learning Management System.